So here we have the problem of given dimensions of two triangles and having to find the area. Now, if you remember from geometry, if we want to find the area of a triangle, it's going to be the formula 1/2 base times height. Because if we actually look at the base and the height, if we were to extend these out in straight lines, this would be a square. And the formula for square is base times height. So if we cut this in half, we get 1/2 base times height, or the area of a triangle. Now where this becomes a problem for us is when we have triangles that we don't know the height for. So if I'm given a triangle like this, and in this case here, if I'm given, let's say this is angle X, and we'll say that this is 12 and this is 10.7. That means that I have to find the height. Now the height is going to be perpendicular to the base. So in this situation, the base is 10.7, but I have to find the height. And if you remember SOHCAHTOA, you'd actually use SOHCAHTOA to find this distance of the height, and then you would do 1/2 times the base. That's a multi-step problem and a little bit unnecessary. If we are given an angle and then two sides that are not opposite of that angle, so in this triangle XYZ, we're given angle X and sides Y and Z, then the formula is just going to be 1/2 times those sides times the sine of the angle. If I were given, let's say angle Y, it'd be 1/2 sine of Y, and I would need the sides X times Z. So, given that I have this, I plug these values in. So I get 1/2 times Y, which is 12, times 10.7, times the sine of 119. Beautiful thing is, this is the formula for the area. So that means all I have to do is put this into my calculator. So I put in 1/2, so that's 0.5, times 12, times 10.7, times the sine of 119. And I get this, 56.15 or 56.2 if I'm rounding to the tenths. So 56.2. Now because this is area, the unit is going to be miles squared, since all of these are miles. And that's my answer for the area of that triangle. Nice quick formula, nice quick problem. Now if I'm given three sides though, it's going to be a little bit different. I have to use what's called Heron's formula, named after the Greek hero. And the formula for the area in this case is the square root of S times S minus A times S minus B times S minus C. And that's for triangle ABC. Here I have triangle HKP. It's not going to make a difference because those are just my three sides. Now S is some new value, and all that is just the three sides divided by 2. So if we think about this formula here and this problem, the area is going to equal S times S minus K times S minus H times S minus P. Obviously, it does not matter which order you multiply these in, since we're multiplying them all together, and order does not matter. And S is going to be K plus H plus P divided by 2. So in this case, K is 7, H is 4, P is 5, divided by 2. That's 16 divided by 2, which is 8. So we have that the area is equal to the square root of 8 times 8 minus 7 times 8 minus 4 times 8 minus 5. Don't worry about knowing that formula, committing that formula to memory, just as long as you understand, oh, you find this value s, and then subtract all three sides from that value and multiply those four quantities together. So now I get 8 times 1 times 4 times 3. So I can find that and take the square root, or again, I could just put that all into my calculator. So I get the square root of 8 times 1, which is obviously going to be 8 times 4 times 3. Hit enter, and I get this, 9.79, which if I round to the nearest tenth, it's going to be 9.8. So that's 9.8 centimeters squared, since my unit there is centimeters, and an area is always a squared unit for 2 dimensions. And that's it. So hopefully this makes sense. Hopefully the problems themselves aren't too difficult. And again, just like law of sines and cosines in general, as long as you're familiar with the pattern of the formula, you can get by these problems.